Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 23, Chemical Kinetics Part 5. Here are our objectives for today's video. Pause here. So we've discussed reaction mechanisms a little bit, just to really talk about why something would be first, second, zeroth order. And now we're going to look at them in a little bit more detail. So most reactions occur, or not most, but many reactions occur in multiple steps. So a chemical reaction overall does not necessarily tell you what collisions are actually happening. And it is the collisions that determine the rate of the reaction. The sum of the steps will always be the chemical reaction. There's oftentimes more than one pathway that a reaction could go through. Pause here. So when there is when there's multiple steps, the slowest step is going to be what's called the rate determining step, or the RDS. That is a step that has the highest activation energy, meaning the highest hill in the reaction diagram. The RDS that determines the rate law and the order of the reaction, and this can only be determined through experiments. Pause here. So we're assuming that this mechanism that's given was taken from an experiment, and the experiment was done well. So let's just add everything together. I'm just ignoring states for right now, but they're all gas anyway. And I'm just going to eliminate anything that is the same on both sides. So overall, I've got NO2 reacting with carbon monoxide, forming nitrous oxide plus carbon dioxide. And now for the rate, all I do is I go to the slow step. And it is just NO2 times NO2, so I made it NO2 squared. It is second order with respect to NO2 and zeroth order with respect to everything else. Pause here. I would just do a rough sketch of the picture. So we've talked about reaction diagrams in the past. A transition state is what happens at the top of the hill. It's never actually observed. It's sort of a hybrid between the reactants and the products, or really a weighted average. These are not intermediates. Intermediates are different. So intermediate is something that is produced, and it's something that you can measure, and then it is consumed in a subsequent reaction. So transition states are a little bit different. And the stability of the transition state determines the activation energy. So if you have a really, really unstable transition state, the activation energy is going to be really high, and you'll have a really low reaction rate. And if there's a way to, say, stabilize the transition state, then there's a way to lower the activation energy. Pause here. Right, so I know that this reaction is exothermic, and I know that it is the first reaction that is my slow step. So overall, all that matters here is that my first step has the bigger hill than my second step, and that overall it is exothermic. There's a lot of different things that you can do with this. And then as far as any intermediates go, what I'm looking for is something that is produced and then consumed. And the answer to this is yes, there is an intermediate. NO3 is produced in the first reaction and then consumed in the second reaction, and it doesn't appear in the overall equation. So therefore, NO3 is an intermediate. Here are the practice problems for today's video. Thank you very much for watching, and have a great night.